All right, my 1.6. Let's see, the first four are the kind with a radical to begin with. So you're going to need to check your answers. So we've got the square root. Okay, so if you want to undo a square root, you've got to square it. You've got to do the opposite of it. So this radical tells us we're taking the square root of this mess. In order to undo that, we've got to square it. And then you can see that squaring and unsquaring cancel each other out. We get that. If you have squared one side, you have to square both sides. So we end up with an x squared right there. As soon as you see that x squared, your brain's going, oh good, we get to factor. This x squared is positive, so we're going to bring everybody over to join him. So the 3x will come over and change his sign, and so will the 40. So we get x squared minus 3x moves to plus 3x. Positive 40 moves to negative 40 equals 0. And that's good. We got a 0. Now we need to factor. The only method you've got is 0 factor property. So we got the 0. Now we're going to factor x and x. Signs need to be different. What two numbers multiply to give you 40, whose difference is 3? That's 5 and 8. 8's the big number, so he needs to make his way to the plus sign. So we got a 0. We've done the factoring. Now set each piece equal to 0 and solve. And then because this is a problem that starts out with a radical, you have to check both answers. Sometimes both will work, sometimes they won't. So let's try the negative 8 first. Square root of 40 minus 3 times negative 8 equals x, and x is negative 8. So this is 40 plus 24. Square root of 64 equals negative 8. No, square root of 64, we only take the principal root, and so that would be a positive 8, not a negative 8. So that number didn't work. Let's check the 5. Going to put it in here. The square root of 40 minus 3 times 5 equals 5. 40 minus 15 equals 5. The square root of 25 equals 5. Good. So 5 worked. We have one answer out of that. Number 2, we've got the square root of 4x plus 44 equals x plus 8. Very similar to the previous one. Let's see, we've got a radical, and he's isolated all by himself there. So we can square the left-hand side. Squaring and unsquaring cancel each other out. If you square one side, you got to square both sides. So x plus 8 squared, that's a FOIL situation. I think we did one very much like that in Thomas's. But if you FOIL this out, x plus 8 times x plus 8, you get x squared plus 16x plus 64. So here's the x squared. He's positive right there. So let's bring everybody over to join him. We'll do a minus 4x and a minus 44. So we get a 0 equals x squared plus 12x and then plus 20. I'm not liking that over there. I'm going to move them over here. So now we've gotten a 0. Let's factor this. X and x, signs need to be the same and they need to be positive. What two numbers multiply to give you 20 that add together to give you 12? It's 2 times 10. So set each piece equal to 0 and solve. So x equals negative 10 and x equals negative 2. Let's check both of those. Let's see, 4 times negative 2 plus 44 equals negative 2 plus 8. So this is a negative 8 plus 44 equals 6. So we get the square root of 36 equals 6. Good, that works. So negative 2 is a good answer. Let's check negative 10 by putting it into the original equation. 4 times negative 10 plus 44 equals negative 10 plus 8. It's a negative 40 plus 44 equals negative 2. Square root of 4 equals negative 2. It's very similar to this, this check over here. We need a positive and we've got a negative on that side. 2 does not equal negative 2. So negative 10 doesn't work. We have one answer. Number 3, square root of 2x plus 5 equals x. This is the first problem here that we need to isolate this radical. That 5's got to go to the other side to start off with. So x minus 5, move him over there. Now he looks just like the previous problem. You've got this radical isolated. Let's square it. If you square one side, you have to square both sides. Got to be fair. 2x plus 5 equals, FOIL this out, x minus 5 times x minus 5. Go first, outside, inside, last, and combine the outside and inside. So you'll get that. We need a 0. Once you see this x squared, you're like, oh good, I get to factor. So you want to get a 0 first. Because the x squared is positive on this side, we want to move everybody over to join. So we get 0 equals x squared minus 12x plus 20. Same problem, except for the middle term is a minus, so we'll have minuses on our parentheses. If you don't like the 0 there, move it. Doesn't matter. X and x, signs need to be the same, and they both need to be negative. What two numbers multiply to give you 20 that add together to give you 12? 2 and 10. Set each piece equal to 0. And move the 10 over, move the 2 over. So we get a 2 and we get a 10. Let's test both of those numbers. So the square root of 2 times 2 plus 5 equals 2. We're testing that. 4 plus 5 under there. So we get the square root of 9, which you know is 3, plus 5 equals 2. Not quite. So 2 won't work. Let's try 10. Got the square root of 2 times 10 plus 5 equals 10. 2 times 10 is 20. So we get the square root of 25, which is 5, plus 5 equals 10. That's good. So we got one answer out of that. Okay, let's look at number 4. Okay, here's the radical. He needs to be by himself. So let's move that 9 to the other side. And now we're very similar to the previous couple of problems. We've got a radical isolated on the left-hand side, so square that. If you square one side, you've got to square both sides. Squaring and unsquaring cancel each other out, so we get 9x on the left. X minus 4 squared, that means to write it out, x minus 4 times x minus 4, and then do first, outside, inside, last, and add up the two middle terms. So you'll get x squared minus 8x plus 16. The x squared is here, and being positive, keep him where he is. Let's move the 9x over to join. X squared minus 17x plus 16. It's a quadratic equation. So let's factor it and move the 0 to the back just because. Signs need to be the same and they need to be negative. What two numbers multiply together to give you 16 and add together to give you 17? 16 and 1. Set each piece equal to 0. And solve. Plug them in as a check. Let's do 16 first. So we've got the square root of 9 times 16 plus 9 equals 16, x is 16, plus 5. Okay, square root of 9 times 16, 9 times 6 is 54, carry the 5, 144, that becomes 12. 12 plus 9 equals 16 plus 5 is 21. This is 21 equals 21, so 16 works. Let's check our 1. So square root of 9 times 1 plus 9 equals 1 plus 5. So square root of 9, that's a 3. 3 plus 9 equals 6. No, that didn't work. So we've only got one answer, just the x equals 16. Okay, 5, 6, 7, and 8 use the rational exponent. So we've got x to the 5/3 equals 32. You've got to get x to the first out of that. You're raising it to the 5/3 power as it is. In order to make that 5/3 be a 1, you're going to have to multiply it times its reciprocal. So the reciprocal of 5/3 is 3/5. 5/3 times 3/5. The 5 on top cancels with the 5 on bottom. The 3 on top cancels with the 3 on bottom. So any fraction times its reciprocal will give you exactly what you want. You want a 1 there. So we're good on the left-hand side. Whatever we've done to the left, we need to do to the right-hand side. So we'll raise 32 to the 3/5. Anytime you've got a number raised to an exponent, put that 32 underneath there. The denominator is the index. So we're taking the 5th root of 32, and then we're going to take that number and raise it to the 3rd power, raise it to the numerator power. So the denominator is always the index. I'm kind of hoping you're getting used to this idea, but if not, feel free to use your calculator. So we're going to put in the index first, put in the 5, then second humpy will get you to 5th root of 32 equals, that gives you a 2. So 2 to the 3rd power, that's 2, 4, 8, or you can do 2 humpy 3 equals 8. So 8 is the answer. You don't need to check these like we did on 1 through 4. 1 through 4 had radicals to begin with. That's when you've got to do your own checking. These others will work. Okay, let's look at number 6. X minus 7 raised to the 3/2. There's that fractional, that rational ratio, that rational exponent. It's isolated over here. It's only the piece raised to the rational exponent that's on the left. So we are ready to raise it to its exponent, to its reciprocal. 3/2, the reciprocal of that is 2/3. Now the 3 on bottom will cancel with that 3 on top. The 2 on bottom cancels with the 2 on top. So those two become 1. 3/2 times 2/3 is 1. So we get an x minus 7 on this side. Whatever we've done to one side, we need to do to both sides. Let's raise that to the 2/3. So let's stick 64 underneath there. Remember, the denominator is the index, and then we will raise it to the numerator. So grab your calculator. We want to look at the cube root of 64, so put in cube first, then second humpy, put in the 64 there. You'll get a 4 for that. And then 4 squared, so we're getting a 16 out of that. So we get x minus 7 equals 16. You still have to solve for x, so add 7 to both sides. So we get x equals 23 on that. Let me think about this for a second. I'm just giving it a look-see here. If I put 23 back in there, 23 minus 7 gives me 16, and I can do 16 humpy 3 ABC2 to check this answer. It gives me 64, so I can put my 23 back in there, get a 16 for that, raise it to the 3/2 and get a 64. That's just to check it. You don't have to check it. Just, just eyeball it sometimes. Make sure your answer looks normal. Backside, we've got 2x to the 1/2 minus 6 equals 0. We need to isolate this rational exponent. The rational exponent x to the 1/2 has to be isolated. So first send the 6 over. Then divide both sides by 2. And now this is what we're doing right here. We need to check this out. We've got square root of, this is the square root of x, but with a rational exponent, we're going to play that game. So square it. So we get x on this side, which is what we want. You're always going to use the reciprocal. That's 2 over 1, which is just 2. Whatever you've done to one side, you need to do to both sides. So we get a 9 out of that. If you want to put it in there, 9 raised to the 1/2 power, that's the square root of 9. That's a 3. 2 times 3 is 6. 6 minus 6 equals 0. You don't need to check those, though. You only need to check these guys that have radicals on them to begin with. Okay, let us look at number 8. X minus 1 raised to the 2/3 power equals 121. Okay, this guy is isolated, so we are ready to multiply, raise him to the power of his reciprocal. So we'll get x minus 1 on this side. We're going to have to raise this side to that same 3 over 2. I'll do that in a second. Radical 121, the denominator is the index, and then we'll raise it up to the 3rd power, to the numerator power. The square root of 121 is 11. I'm hoping you know that. 11 raised to the 3rd power, I think, is 1331. Let's check that out. Clear. So we want 11 humpy 3, 1331. Good. Then you got to get x, not x minus 1. Nobody cares about x minus 1. Add 1 to both sides. So we get a 1332. Okay, 9, 10, 11, and 12 are the substituting ones, the mu ones that we only did 2 of in Thomas's section, but we're doing 4 of them here. You will have one on your test, so save your notes for this. You won't have any on the final, so you don't have to worry about it for the final so much, where you don't get to use like old MyMathLab stuff. Okay, number 9. Change this problem. This is a bad problem. We want x to the 4th minus 257 x squared plus 256 equals 0. I'm not sure how I messed that one up so badly, but I did. So when you've got x to the 4th and x squared, you know that's called quadratic in form. It's a quadratic wannabe, and we've got to turn it into what looks like a quadratic, like an x squared and an x term and a number term. So we are going to take whatever piece sits there behind the b number, and we're going to substitute this funny little letter mu for that piece. So we've got a 0 here, equal sign there, 256, everything rolling along like normal, plus sign. Oh, there's an x squared. We've decided to substitute in a mu to make this look a little more normal. Then we got a 257, then a minus sign, and then this guy is the square of that one. So then if our x to the 4th is the square of that one, what we put here will be the square of the mu. These will always work out like that. They will always set them up for you so that you're going to have a mu squared here and a mu there. Now that's a funky little variable, and like I explained in Thomas's, that's so that when you end up here with mu equals, you don't stop there. You're like, oh, something's weird here. You've got to go back and resubstitute and make it back talking about x's. But for now, we're talking about mu's. So mu's go in the first spots. Signs need to be the same, and they need to be negative. What two numbers multiply to give you 256 and add together to give you 257? That'd be 256 and 1. So we've got the 0, we did the factoring. Now let's set each piece equal to 0. And now this is not done. This problem is not finished because the problem is talking about x's. So your answer has to say x equals. Right now it says mu equals. So we substituted for mu. We're going to have to undo that substitution. Everywhere we find a mu, we're going to go back in and put x squared. There's another mu. Let's get it back to x squared. We want to talk about the language of x's, not mu's here. And now, like you've been doing a couple of problems here, if you've got an x squared, take the square root of that side. Squaring and unsquaring cancel each other out, and we get x. But if you take the square root of one side of the equation, you have to take the square root of both sides of the equation. Let's figure out what the square root of 256 is. Get 16 there. Remember, you put the radical on, so you have to consider both a positive and a negative version of that number. Same thing's going to happen over here. We need to put radicals on because we want an x. We put the radical on, so we need a plus and minus and 1. So we get 1, 2, 3, 4 answers. Positive 16, negative 16, positive 1, negative 1. We got 4 answers. That's what we were looking for, is 4 answers. Alrighty, let's look at number 10. X minus the square root of 17. Nope, that's not what it says at all. X minus 17 on the square root of x plus 52 equals 0. Again, this wants to be quadratic, but it just doesn't quite cut it. We need an x squared, we need an x, that kind of thing, a variable squared and a variable. So let's do some substituting. Let's let mu equal, remember it's always going to equal whatever sits behind the b. So that in this case is the square root of x. So we're going to transform our problem into a mu, this weird little Greek letter that we're not used to using, that is, I'm hoping, will stop us right here. We won't stop and say, well, there's our answers. We've got to get back into the language of x. That's the point. Okay, so let's start at the back. 0 is normal, equals is normal, 52, plus sign. Oh, there's the square root of x. We've decided to sub in mu in place of it. Then we've got a 17, then we've got a minus sign. This x is that one squared. If you want to get rid of that radical, remember, square it. So this is the square of that. So this needs to be the square of that. And they'll always work out like that. Then it'll be an easy factor, or at least it'll be a factorable factor. You won't have to use quadratic formula or anything like that. Signs need to be the same, and they need to be negatives. What two numbers multiply to give you 52 that add together to give you 17? If you play cards, you know that 52 cards in a deck, there are 13 cards of each of 4 suits. So 4 times 13 gives you 52, and they add together to give you 17. So let's set each piece equal to 0. Okay. Now, I'm hoping this is why we use this funny little letter. Instead of picking Y or a Z or a P, whatever, we pick something you've never used before, so that when you stop here and you say, okay, they're my answers, let me go put them in my math lab. No, those won't work up here. If you put a 4 in there, it's not going to work. What you need to do is you need to get back into the language of x. So come back down here and resubstitute. In place of mu, put the square root of x. In place of mu, put the square root of x. Now, we got to get x. How to get x is to square. If you square one side, you have to square both sides. So just going down the row there. Squaring and unsquaring cancel each other out. We get an x. 4 squared is 16. Sweet. Squaring and unsquaring, 13 squared is 169. So we get our 2 answers there. All right. Let's see. I think I'll start this one here. Nah, let me move it up. Okay, let's look at 11 and 12 here. Okay, another mu problem. We need to make this look a little more quadratic. So we're going to let mu equal whatever sits behind the b. That's x to the 1/3. Okay, so let's go translate this by substituting in mu's. Get a 0, get a 5, get a minus. Oh, there's x to the 1/3. Substitute in mu, then a 29 and a minus. This is the square of that, so this needs to be the square of that. So mu squared, and put a 6 up front. Okay, so now it is quadratic. It's got a mu squared and a mu. That's good. We're ready to factor this thing. Okay, I'm seeing 6 and 5, and I know that's close to 30. 6 times 5 is 30, and we want to get close to that. We want to get a 29. So I'm going to go ahead and try 6 mu, and then the signs need to be different. And then I'm going to put a 5 at the back. That way I'm getting a negative 30 mu, and the inside is a plus 1 mu, and that gives me exactly what I'm looking for, that negative 29 mu. So now let's separate each piece out and set them equal to 0. So mu equals 5 there. Over here, 6 mu equals negative 1, and then divide by 6. All right, got that funny little letter mu, hoping that you say to yourself, can't stop there. And sure enough, this problem asks you to find x. You've got to solve for x. We're solving for mu. We can't stop there. Let's go and resubstitute in. So in place of mu, I'm going to resubstitute in my x to the 1/3. In place of mu, I'm going to resubstitute in my x to the 1/3. So equals negative 1/6 equals 5. Now, in order to get this to be x to the first, I'm going to have to multiply that exponent times its reciprocal, times 3. 1/3 of 3 is a 1. That's cool. X to the first, that's what I'm looking for. If I do that to one side, I need to do it to both sides. You can do this in your calculator. Be sure to put negative 1/6 in parenthesis and then humpy 3. But negative raised to the 3rd power, negative times a negative times a negative is a negative. 1 times 1 times 1. 6 times 6 times 6, maybe 216. Let me just make sure. 6, humpy 3. Sweet. Okay, on the other side, same thing. I've got to raise this to the 3rd power, and if I raise that to the 3rd power, I've got to raise them both to the 3rd power. X equals 125. So we end up with 2 good answers there. Okay, let's look at number 12. We've got x plus 3 squared plus 4 times x plus 3 equals 0. Okay, again, this kind of looks like it's quadratic. We've got an x squared and an x and a number, but we need to make it more specifically look like a quadratic. So we're going to let our funny little friend mu equal whatever sits back behind the b. In this case, it's an x plus 3. So let's go subbing. We've got 0 equals, there's a 3, there's a plus sign. Oh, there's an x plus 3, so let's put a mu, then a 4, then a plus sign. Then this x plus 3 squared is this one squared. So we need to put here that guy squared. So mu squared. And now we've got a normal looking quadratic that we can factor. Signs need to be the same and they need to be positive. What two numbers multiply to give you 3 that add together to give you 4? Set each piece equal to 0. And now, that's why we're using this weird little letter, because I don't want you to think, okay, I'm done with the answers, because this problem is not a mu problem, it's an x problem. So go back and resubstitute. Put in place of mu, put in x plus 3. Put in x plus 3. That was a negative 1, so there we go. And now we need to solve for x. So x equals negative 6. and x equals -4. If you want to check them, you can, but you don't have to. A -6 plus 3 is a -3. -3 squared gives you a 9. -6 plus 3 gives you -3. 4 times -3 gives you -12. 9 minus 12 is -3. -3 plus 3 gives you 0. It'll work, and so will the other one. See you later.